All right, everyone, welcome to the first episode of the Cloud Security Lounge. I'm your host, JB Havia with Izar, and we are glad to welcome today Steve Springet. Steve, welcome to the Cloud Security Lounge. Thanks for being our first guest. Steve, you are the author of the CycloneDX specification, which is one of the most famous SBOM specification. You are also working on the CycloneDX specification core working group. Our listeners can find you or get in touch with you on LinkedIn, in Twitter, and obviously we'll let your contacts in the notes of the episode. About me, I'm JB, so I work at Datadog. I was co-founder and CTO at Screen, where we built application security, and we got acquired by Datadog in 2021. And now I'm building the security products over there. Obviously, in that journey, I'm not alone. For instance, Izar is also working at Datadog.
Yep, and been doing the security thing for a long time. OWASP aficionado. That was the first place where I saw Steve a couple of years ago at OWASP Cali. I wandered into your presentation totally by mistake, to tell you the truth. But you started to be so interesting that I said, you know what, I'm probably in the right place. So after 45 minutes, I came out thinking that I understood what SBOMs are all about.
AppSec Cali is a great conference. And, the fact that I could persuade you to stay in my room as opposed to going out to enjoy the beach is, thank you for that. So I'm honored to be your first guest on the podcast, and congratulations on its launch.
Thank you, Steve. Would you like to start by quickly reminding the audience what is SBOM and maybe how that relates to security?
Right. So a lot of descriptions for SBOM actually break it down to a simple list of ingredients, right? Food, for whatever reason, we always use food as the analogy. People are hungry, I guess. But when you look on the back of a packaging of a food label, you see a list of ingredients. That's the common analogy. I don't really prefer that analogy, but it's the overall push in the industry has been around software transparency, and making transparent the third-party and open source components that you use is one of the objectives within the overall transparency movement. And software bill of materials is just a mechanism in which facilitates that transparency. But there's a lot of things that you can do with a software bill of material. And it is much more than a simple list of ingredients.
Which I think gets us to our first question. So what would you say we're trying to solve with SBOMs, Steve?
That's a really great question. The transparency of an SBOM or a bill of material in general is going to lead to a lot of different use cases, right? The primary motivating factor for the U.S. federal government, at least initially for the transparency effort, was just about identifying those at-risk components, those things that have known CVEs, for example, the things that might be out of date, or maybe the supplier is no longer in business. So those are like the immediate type of security use cases that you can achieve with a software bill of material. But obviously, there's all kinds of other security use cases. There's authenticity use cases. There's integrity use cases. Open source is the ultimate supply chain, and components are continuously modified and renamed and redistributed ad infinitum. So being able to track all of that is also very useful security use case. Did you copy and paste vulnerable code from Stack Overflow? Fantastic. Documented in the SBOM. So it's these types of security use cases that can also be represented as opposed to, much more things. But even within outside of security, security is, we might think of it as the center of the universe, but there's all kinds of other use cases. There's license and intellectual property use cases. There's use cases for mergers and acquisitions that incorporate both security, license IP, and other types of use cases as well. So it's really about what type of information can go into that bill of material and transparently provide that information out to the people who need to be able to analyze it. And depending on your role and what type of data you care about for that role is really going to dictate what the use cases are and what you can do with that.
So you touched on a use case here that I hadn't thought of before, the GitHub one, the cut and paste. And I think that links a bit into the fact that perhaps because a lot of people see the analogy of the food label and stop there, or perhaps some people are more familiar with some different or unique format of SBOM, of which we come to learn that there is quite a number. And could you just visit a bit this I don't know even if it's a battle, but the fact that we have this many different SBOM standards out there, and if, I don't know, they apply to different cases, and then go and explain a bit more about this GitHub case that you mentioned?
Sure. Yeah, I mean, there's two primary formats in existence today. There's CycloneDX and there's SPDX. They both solve very different problem spaces, or they came from entirely different backgrounds. SPDX grew up in an era of manual use cases. It's a fairly old spec, and lawyers be lawyering because they came from that license and intellectual property use case. The spreadsheet format is and was and currently still is a viable format for SPDX, right? Being able to make annotations, comments on, hey, this license may look iffy because of X, Y, and Z. Perfectly valid use case. But that's kind of the era in which SPDX grew up in. Not a big fan of their file format, which is kind of why CycloneDX exists in the first place. But they've done a number of great things in terms of just standardizing how licenses, open source licenses, are identified or how they can be expressed. For example, I might have a dual licensing where I could either apply maybe a GPL without the class path or some other license, right? And you can say either you have to do one license or the other, or maybe you have to do two licenses to be able to use that component, right? So they've developed both the identifiers and the expression languages, which are in wide use today. Cyclone fully supports that and has since version 1. But those are the two big formats. Cyclone obviously grew up in a later era. It grew up in an age of DevSecOps automation, right? We had to, as security professionals, we didn't have to automate for any kind of efficiency or anything like that. We had to automate for survival, right? We had typically very small security groups, and we were serving tens of thousands of developers in some cases, and we had to automate. And so CycloneDX grew up in an age of automation. So the object model in Cyclone is kind of geared toward being highly automatable. It's not the perfect object model. It's not designed to be the perfect object model. It is designed to be highly automatable. So there's a very big difference between being able to automate something versus being able to automate continuously that same thing using multiple different tools until the end of that SBOM process is done. So we grew up in entirely different eras. Obviously SPDX came from licensed and intellectual property, and CycloneDX came from the OWASP and security world. We've kind of encroached on each other's turf, so to speak, a little bit. And the next version of Cyclone actually is going to have more licensing capabilities than SPDX supports. So that's something that we're really proud of. The copy and paste issue is a really big, valid one, actually. Not just for the copy and pasting of code, but just actually making derivatives of things, right? A very common pattern that you get into, especially with large applications, is once you have a lot of components in your application, tight coupling becomes a thing. And simply upgrading components may not necessarily be viable, right? Because you upgrade this component, well, then you have to upgrade this other thing, which means you also have to upgrade this other thing, which means that now your application breaks. So things are a lot more complex in the real world. So a lot of organizations, what they do is they fork some of these components because of tight coupling. They fork them. They make those the backports to otherwise vulnerable components, and they can describe what those backports are, right? They can describe the commits, who made them. They can describe the diffs, what specific changes were made. Why were those changes made? It resolves CVE X. And that way, when you consume that bill of material, now all your lights don't go off, right? Now you know that, hey, you're using an otherwise vulnerable component, but this vendor actually did the right thing, right? They backported. I'm no longer susceptible to this vulnerability. It's a very, very common thing with, real applications. So these are things that go beyond just a simple list of ingredients that are really important.
And so do you see vendors actually going to that level of precision and annotating their own dependencies with that level of care?
Yeah. So my own employer, for example, I work for ServiceNow, and our MVP of our SBOM contains, the normal things from the NTIA minimum elements, in addition to, I think we also have licenses in there as well. But, like any big platform, whether you're ServiceNow or some other big platform company, you're going to have tight coupling, and you're going to be using vulnerable components. It's inevitable. But, we are responsible platforms, right? We are responsible vendors. And we've got hundreds of components that we've forked. We've backported security fixes so that our customers are not vulnerable. So while the MVP of our SBOM is not going to have that information, we absolutely need to include that, because we don't want, as vendors, we don't want our support staff to get overwhelmed when consumers actually start consuming these SBOMs and thinking that we're using a bunch of vulnerable components when in fact we're not. It wastes their time, it wastes our time, and we need to think about the customer experience.
So you're describing a richness of format here that I have to confess I was not aware that SBOMs were reaching into. And I wonder how that connects with other formats that have started appearing to continue the process of informing risk based on an SBOM, like VEX or VDR. How do you see those things progressing? Do you see them becoming part of the SBOM, or still being separate formats?
In terms of the pedigree, I believe it's kind of unique to Cyclone at this point. SPDX can do a little bit of that, but it's not quite to the extent that we can with Cyclone. VEX is going to be extremely important. One of the pushbacks that vendors have in general is that they don't want their support staff to be inundated with calls, and being able to describe things like, I'm not vulnerable to, Log4Shell because of X, Y, and Z is kind of important for vendors. There's a lot of studies based on, whether you go to different SCA vendors or different research vendors, whatever, that the overwhelming majority of vulnerable third-party components are not actually exploitable in the context of the application in which they're running, right? We all run vulnerable components. It is inevitable, but are they actually exploitable in the application? Most of the time, they're not. And being able to communicate that is really important for vendors. And it helps consumers actually focus on the things that matter.
So the way you described annotating your own SBOM with what you forked and what happened, so it feels like really ideal to me, but it also feels like pretty hard to put in the workflow of developers, right? How do you manage to guide them through doing that?
Lots and lots of glue. Duct tape and super glue. Creating an SBOM, which is why I've always considered creating a bill of material as a process. It is not a one-time event. It should never be viewed as a one-time event. And anybody who does view it as a one-time event, I think really doesn't understand the true nature of what a bill of material actually is. You can start creating them with your package manager, for example, but your package manager isn't going to know a lot of different things, right? If I run npm or Maven or something, my package manager is not going to know that I forked this version of Apache Commons IO, right? It's just going to see Apache Commons IO. Or maybe it will even see my renamed version of Apache Commons IO dash custom or whatever, right? So package managers are not overly intelligent. They also are going to be completely blind when it comes to non-software digital assets, right? What are the fonts? What are the images? What are the services that my application also depends on, right? Do I rely on some type of service to fetch stock quotes from the internet? Great. That should be part of my inventory because it is a dependency of my application. But your package manager doesn't know all these other details, right? It just knows what you've specified in the manifest. But if you have forked all these things, hopefully you have documentation on what that is. And if you do, then you can describe the modifications. And if you have references to the defects, then you can start pulling that information together. And once you have this data, then you can describe, oh, well, I see that this change actually affects this defect over here, which actually is a security thing, which is a CVE over there. So now you can start pulling all this data and start populating into your SBOM, which is one of the things that we're looking to do within ServiceNow. So when I said duct tape and super glue, yes, I kind of meant that because we all have different systems. Some of us use GitHub, Bitbucket, GitLab, whatever. We use Jira, we use ServiceNow, we use GitHub Issues, we use all these different things. And there isn't a single tool that is going to be able to work with everything. So a little bit of duct tape and super glue is kind of necessary, at least for the time being, to get to that next level.
So you're talking about in the future we're going to get there. But every time that I participate in a discussion that has SBOMs, somebody brings up okay, we have an SBOM and it's even a good one, but what do we do with it now, right? Do we just publish? Do we sign it? Do we store it somewhere and never look at it again? So if you had to describe an ecosystem of automations around the correct use of an SBOM, trying to extract the most value that you can, what are the bits and pieces that you would put in place to put the glue and the tape on?
Yeah, I think the first thing that any organization that adopts SBOM is trying to figure out what that radius of transparency looks like. We first have to be open and honest with ourselves as companies about what really is in our software, right? What are the license issues? What are the security issues that we have? And based on that information or requirements that we might have from regulations or whatever, we need to figure out what that radius of transparency looks like. And do we sign our artifacts? I'm in big favor of signed SBOMs. Cyclone actually supports envelope signatures in addition to external signatures. So if you only want to sign part of your SBOM and then maybe sign the full thing with a different signature, you can absolutely do that. Perfectly valid use case. And there's a lot of reasons to do that. But signing is certainly something. Having control over your distribution of your SBOM is something that most most software vendors are concerned about. While we don't want to necessarily leverage security through obscurity, it's certainly not a bad thing, right? As long as it's not the only thing, right? So kind of limiting what the radius of transparency looks like so that only authorized users can actually get access to the software bill of materials is a good thing. In terms of use cases, there's been a lot of talk on quality. And quality SBOMs are multidimensional. There's a group within OWASP, it's called the Software Component Verification Standard, or SCVS. SCVS itself is is a way for organizations to measure and improve their software supply chain assurance. SCVS is referenced in its entirety in NIST SSDF. But the SCVS project is also working on a BOM maturity model. And it's a formal taxonomy of all the different types of data that you could theoretically put in a bill of material, covering software, services, hardware, configurations, other types of data, all kinds of other things that could potentially go into a bill of material. Every single field has an identifier, has a description, and it has a level of effort. And as a consumer of a bill of material, you have to kind of know what is in there and does it provide the necessary data for your intended use case. And what we envision in the future is people taking up the SCVS BOM maturity model taxonomy and creating new categories of tools, specifically SBOM profilers, so that you can analyze the bill of material and it will actually tell you whether or not it has the data for the type of analysis that you want to perform, right? You could get a bill of material and it may not actually have a CPE or a Pearl, and you'll run it through some kind of security analysis and you'll say, oh, great, no vulnerabilities in it. Perfect, thank you, vendor. When in reality, it doesn't have the data necessary for you to perform that type of analysis. So there's a lot of talk about that, and we're trying to deliver a viable taxonomy here within the next month or two. The other aspect of quality is accuracy, right? How accurate is the data that's in the bill of material? Accuracy is a much harder problem to solve, right? For example, if I generated my bill of material from NPM or Maven, and I do have modified components, but I don't document that, well, how accurate is that bill of material? At least it's not going to be accurate for those modified components that I have, and the consumer is not going to know that, right? How accurate is the license? Is what the stated license that's in the repo actually accurate? Or is there other legal considerations that we need to also take in consideration, right? So the accuracy is a much harder problem to solve, and I think as an industry we will eventually get there. There's a lot of tools that are being created that actually do target SBOM quality, and some of those tools will be supporting the OWASP software, the BOM maturity model that I talked about.
Super interesting. I think that also brings the topic of like freshness of the SBOM, right? Which seems similar in terms of quality, efficacy, as you described. That's something that we care about at Datadog. So maybe I wrote a quick schema that I'm going to share. So in terms of SBOMs, you can imagine that a lot of different things can be used as a source for SBOMs, from dev IDEs, continuous integration, the side scanning that would be like purely cloud integrations, for instance, and the runtime. And so I guess what you describe is that usually vulnerabilities, or often vulnerabilities, are not directly within SBOMs, and what you do later with the SBOM can be anything. And so each organization or vendor might have a different approach. Each of those SBOM sources have pros and cons, and things that might be more or less precise, more or less information. And yes, so obviously the Datadog one is the runtime one. And so one thing I'm very curious about, Steve, is, so given each of those sources can have different information, different data sources that they could leverage in order to enrich the SBOM, what are the kind of things that we can share within a SBOM that go beyond the pure list of software materials?
Yeah, I think the runtime environments are really interesting. We refer to that within Cyclone as OBOM, or operational bill of material, which is kind of a superset of your SBOM, your maybe the hardware that it's running on, maybe the container images that you're using. Maybe it even links out to the organizations, the parties that are responsible for the operational aspects of that. So we actually refer to that as the OBOM. But yeah, I mean, we've always tried to position SBOM in general as a way to provide transparency that would not be a quote unquote roadmap to the attacker, right? The adversaries, I mean, providing a list of ingredients, the adversaries are smart. They can figure that out on their own. It's not hard, especially if you have a remotely exploitable vulnerable component, right? It's not difficult. Existing exploit code is going to test for the existence of all those things anyway. But there are other things that you can put in an SBOM that could, in fact, be a roadmap to the attacker, which we need to, again, when we're talking about the radius of transparency, we need to be cognizant of. So, for example, if we described in a software bill of material the precise steps in which that software was created, yeah, that as an adversary, that gives me a way to threat model their build process and, potentially exploit that in the future. Do I actually want to provide that out to my customers? Probably not. That would be a case where the radius of transparency, if I have that data in my SBOM, I probably want to keep that fairly, close, right? I probably want to keep that within my organization, or have really strict contract provisions that would exclude, divulging that information out. But the pure inventory use case is kind of what we're capturing. But again, we try to not provide a roadmap to the attacker, because once we start going down that route, then you're going to have more and more pushback from vendors. So what we do see are a lot of organizations producing both externally consumable SBOMs, so things that don't have all that other information and will not be a roadmap to the attacker, versus internally used SBOMs, which have a lot of that other metadata in it that's going to be really useful for the organization that produced it, and really bad if it got to the wrong hands.
So you mentioned the vendor pushback, and I think it can't go unsaid that when the US government came out with their first memorandum and now the cybersecurity policy, which both mention the SBOM, we have seen some pushback from vendors, basically in saying, okay, you guys are requiring us to create these SBOMs and to publish them, but nobody's telling us what exactly we're going to do with it. So you are going to push us into building this whole process inside and this whole complex way of maintaining assurance and whatnot, and then giving it to you, and then what happens? What do you think of that pushback?
I'm surprised that the vendors are pushing back, but I guess it's to be expected, because even if the vendors start asking their suppliers for SBOMs, what are they going to do with it once they get it? There is not a shortage of tools that produce SBOMs, right? We have literally hundreds of them available today. There is a shortage of consumption tools. So what do you do when you actually get an SBOM? Things like OWASP Dependency Track, which it's now celebrating its 10th anniversary, was specifically designed for this purpose, right? It was designed before SBOM was even a term. It basically, the original use case was for bill of materials, right? I needed a way 10 years ago to track what are called server appliances. These are things that people deployed in their data centers. And at the time, I needed to track the hardware, all of the firmware, the operating system, OS packages, application libraries. I had to track the entire thing. And that's the original use case that Dependency Track was built on. And now we've got tens of thousands of organizations, including multiple federal agencies, that have standardized on their use of SBOM consumption using that tool. But that's just one tool, right? And it only supports CycloneDX. So what happens if you standardize on SPDX? Well, there's even fewer consumption tools for that, especially at the enterprise level, right? If you are an enterprise where you have quite literally hundreds of thousands or even millions of devices in your environment, and you are going down that SBOM route and trying to do everything, right? What are you going to use? There's not a lot of options out there, other than dependency track and some other things that are kind of in the works. But what do you do at an enterprise scale? And how do you tie that back to assets in your CMDB? That's kind of a growing field. But, the pushback is legit. I've actually talked with, NSA reached out to me last year because they were doing some research. Couple other analysts reached out to me, and they had some questions on dependency track and a few other things. And because they were trying to provide some guidance for the federal agencies, right? So at least on the consumption level anyway.
Steve, something you mentioned during the preparation was SBOM. Could you tell us more about that?
The concept of services came about, several years ago. I was actually working on a mobile app, and we had a transitive dependency that actually phoned home to some service, and we had no idea what this service was because we weren't doing the one making the call. It was a transitive dependency. So at that point, it became kind of obvious to us that we need to start tracking services as part of our software inventory, just in a normal SBOM. So we added support for services into the spec, and it's been hugely successful, right? While your package manager may not necessarily know what your services are, there are a lot of tools out there that can discover what your services are and augment those in your SBOM, right? But then what happens if you start taking away the software components and you're left with only services? Well, that's essentially what a SASBOM is. It allows you to describe all the services that are in your environment. Maybe you want to describe a microservices architecture, or maybe you want to describe maybe a system of system. For example, the various computing components in an automobile, for example. So it allows you to describe all these different types of services and their dependencies to other services. The interesting thing about SASBOMs is that it's really about what we want to protect. In the case of an SBOM, well, this is primarily intended for software that we would deploy, right? And it's our environment that we need to protect, right? If we want to protect our environment, we kind of need to know what is that vulnerable version of Log4j, right? So that we can protect that environment. Well, in the case of SaaS, well, we're paying somebody else for that service, right? It's not the environment we want to protect, it's the data. And so the data and the data classifications and the directional flow of data and the trust boundary traversals, these are types of things that we can represent in CycloneDX because, again, it's really about what we want to protect.
So wait, you're blowing my mind here. let me bring this to a place that's near and dear to me, which is threat modeling. And I heard you describe the OBOM, the operational bill of materials, the SBOM with sort of like almost a system of systems approach to what services we're using. Of course, we have the SBOM. It seems to me that you are building to a set of different BOMs that at the end of the day, they will have enough resolution to describe exactly what's running, what's talking to whom, which pieces are in play and what's not. And at some point, if I have that and the system doesn't have a threat model yet, that would have a lot of information that I would need to actually build a good one.
That is absolutely where we're going. And in fact, I think you will be happy to note that in CycloneDX, we have these things called external references. And they're basically like things that are outside of the component or service that are related to them. It's our way of establishing relationships within CycloneDX. And you'll be pleased to note that we're actually about doubling the number of external references that we support. We're including things like maturity models. So if you have like an OWASP SAM for the organization or a BSIM for the organization, you can reference that. You can reference all your static analysis results, maybe your pen test results, maybe any kind of certifications. And yes, threat modeling is a threat model is a new type of external references. So if you have like something in OTM format, maybe it's just a pure data flow diagram, whatever you have, you can absolutely reference these things or actually include them in your bill of material itself. So yeah, because I'm a big threat modeling person as well. And that's kind of what my team does within ServiceNow. And so being able to represent all this different type of security data is kind of essential depending on the type of use case that you want to perform, right? So yeah, that's kind of where we're going with this whole thing. And the SBOM capabilities in CycloneDX actually allow, I think there's enough granularity right now to actually convert a CycloneDX bill of material, a SBOM, into OTM. And for those that may not know what OTM is, it's the open threat modeling format. It's put forth by a company called Continuum Security. They make a product called Erius Risk. I'm not advocating for this particular product. However, traditionally, what has been problematic in threat modeling is that the outputs have always been tool specific. So if you're using multiple tools, interop has always been a challenge, and OTM is an effort to kind of standardize that. There's enough data in CycloneDX to actually generate an OTM that would be useful for the basis of a threat model.
I will be looking into that.
I'm sure you will, Isa.
I'm sure you will.
I'd like to share like Datadog approach to SBOM and to, or at least how do we source SBOMs, right? So the goal is to really have something that is low friction. So here what you can see is basically just the what we call the service catalog. It's a list of the services that you may have in your organization, and it includes like ownership, information about the repository, and obviously telemetry with information such as like performance, where we give you Datadog APM give you in real time like latency and the requests per second, etc. But we also have the security tab, and so just based on the APM, nothing like specific to add here, we can gather from the runtime context the vulnerability information. And so, to your point, Steve, this particular flavor of SBOM that we are gathering is what's provided by the application runtime. So, what libraries are actually required when the application is starting and running, if some libraries are loaded later. So it's a different view from what you would get from the source code, because it's not like package.json or maven.xml. It's what's getting actually loaded on that specific execution, right? Just from a purely observability tool, we can use that dependency data and see that what are the actual vulnerabilities that we got there. And so one topic that we touched but didn't discuss yet deeply is the topic of prioritization, because so okay, once you have those 95 vulnerabilities found, what do you do? So one of the things that thanks to all of the runtime context that we have, one of the things that we can do is actually adjust the severity of the vulnerabilities. So here we see that specific service didn't receive any suspicious requests in the last month, which seems to say that yes, this service will never be attacked, right? Like no internet noise ever reached it. So in that case, we're confident enough that we can lower the severity of that specific vulnerability. So that topic of prioritization, I think, is key as one of the implementations that we do utilizing SBOM. And so I would love to hear more about that, Steve. Is it something that you think is like a first-class SBOM citizen? What kind of how do you prioritize the dimensions of prioritization?
Yeah, it's a hard problem. I mean, too many organizations, I think, rely on CBSS scores, which do not communicate risk in any kind of way. Some newer, like Dependency Track, for example, and a bunch of other tools, they're starting to include things like EPSS, which will give you, the probability of a particular thing being exploited in the next 30 days, right? EPSS is really good for applications and operating systems and these types of things, but it's not overly good for libraries, right? It's better for other things. So being able to prioritize, because if you have limited cycles, right, most teams have time box constraints. So if you have time box constraints, it's kind of important to be able to prioritize your work. And if you know exactly what the probability of something being attacked is going to be based on maybe your architecture, maybe how things are deployed, or maybe whether or not, your telemetry actually tells you that, hey, I have this thing and people are starting to test it. Yeah, you should probably prioritize those things. It all goes back to like different metrics. What do you want to measure? Mean time to recovery, for example, for vulnerabilities is something that we absolutely want to measure. Having that transparency, while good, what are you going to do with it? And being able to respond quickly in the event of an incident, is kind of the utopian thing that we all need to get to.
Do you see that SBOM as a required vector for this kind of information? Is there, you mentioned EPSS, should that fit within SBOM? Is it like...
I don't think so. EPSS is very dynamic. I mean, it's updated, scores are updated every 24 hours, I believe. There's things that I believe should be in an SBOMs and things that should not, right? Dynamic data, for the most part, probably doesn't belong in an SBOM. Now, and that includes like EPSS scores and vulnerabilities and that sort of thing. There is one use case for including vulnerabilities in the SBOM itself, and that's for audit, right? What were the vulnerabilities at a given specific point in time for this particular piece of inventory? Perfectly valid use case. But for the most part, these things should be entirely decoupled. And CycloneDX, for example, allows you to decouple your software inventory from your vulnerability information so that, one, your SBOM is static and it's, specific to a release of something, and your vulnerability information is dynamic and can change, multiple times a day.
So wait, let me just make sure that I understood you. You mean audit in terms of I'm publishing the packages that are in use in my product, and at the same time, I'm publishing the known vulnerabilities on those packages at that time. Did I get it right?
Yeah, I mean, you just use it for that kind of audit, but I was thinking more about some more, I guess, different types of use cases. For example, NTSB, when they have to, National Transportation and Safety Board, for example, in the United States, when they have to investigate what software was in play when a major incident actually happened, well, then having all that software cataloged along with the vulnerabilities that software had, I think is a very useful use case. And you'd probably want to have all that data together. And SCA tools, for example, are very common to put all this data together because, again, it's here is the data that we know at a given point in time, and it's only valid for that point in time. It doesn't affect 5 minutes later. It's invalid 5 minutes later, but at this given point in time, this is the vulnerabilities that we knew about.
Is that a capability that Dependency Track has?
Yes, we can isolate both the SBOMs and the VEX, for example. Consumption use case, for example, is, you consume a bill of material, and that contains your inventory. And then you consume the VEX, which, if the inventory lights up your dashboard because of all the vulnerable components, your VEX is your negative advisory, right? It's going to start calming those lights down, right? So that as a consumer, you're only looking at the things that actually matter, not all the things that might have vulnerabilities in it.
Tim, I think we're getting out of time here. Is there any topic you'd like to touch or discuss that we didn't go through?
Yeah, I mean, CycloneDX is currently continuously evolving. We are working on 1.5 of the spec right now. We're trying to get that pushed out in sometime in May. We're working on 1.6. beyond that. So 1.5, if we're introducing machine learning bill of materials, we're introducing manufacturing bill of materials, which is the idea of how things were created. We're introducing bill of attestations. And then in 1.6, we're introducing cryptography bill of materials. So being able to track all the cryptographic assets, the algorithms and protocols and everything else, so that we can start analyzing risk for post-quantum systems and applications. And even beyond that, we're looking at, things like entry and exit points and all kinds of other things. So if this is something that your audience is interested in, visit CycloneDX.org/participate. There are links to our Slack channel, to our GitHub organization, to our mailing list. Get involved. We are an open community. OWASP projects like CycloneDX are open for anyone, whether you are a large organization or an individual contributor. Everyone has an equal seat at the table.
And if we have people who, for some reason, just got into the SBOM bus now, hearing us talking here, what would be the order of resources that you tell them, hey, go look at this thing and then at this thing to start getting a foothold?
Yeah, I would take a look at the ntia.gov/SBOM. It's going to have some really high-level use cases and why this is even a thing that we're talking about. So it's going to have a lot of consensus-based documentation out there. But also take a look at CycloneDX.org/capabilities. Because while the world has kind of gone SBOM crazy, there's actually a really big ecosystem outside of just SBOMs, right? You can do hardware bill of materials and SaaS-BOMs and all these other things. So really start looking at what as an organization do you care about, and then start looking at the specs to see if those align with what your organization cares about. But CycloneDX has a pretty extensive resource of capabilities as well as use cases and examples that I would encourage folks to take a look at.
Cool. And as a tool, you would suggest people to start looking at OWASP dependency track. Would that be a good first one? Or
for consumption, yeah, it's probably there's a lot of consumption tools, everything from command line things that you can do quick and easy to things like dependency track, which is more of a platform. But start consuming them, start playing with them. Things like dependency track are used by, again, like tens of thousands of organizations and federal agencies.
One thing we didn't mention, and that is also like a very easy way to start, would be Trivy, for instance. So like just giving one example of what you can do, just working on a specific Google image. Here Trivy is downloading like the vulnerability of a database of vulnerabilities, and so it will just go through that specific Docker image, and it will make the best to guess what are the software installed on it, whether it's like operating system packages, or if it's like the application that is installed there. Trivy will make their best to find the files and analyze what are the dependencies. And so we can see like a pretty hard to consume input, but so you can also ask Trivy to output data in JSON, for instance, and here you would get some SBOM in JSON format. So that's also like a very easy way to get started and get your hand on a specific SBOM.
Yeah, absolutely. Trivy is a great tool. I've been using it for years. They support SPDX and Cyclone, and I think they also support like CIS benchmarks, if I remember right, and stuff like that. So it's a fantastic tool. We use it all the time in our CI pipelines.
Thanks a lot, Steve, for sharing all of this knowledge with you. I think I have better understanding of what SBOM are, but I've also got a lot of questions because that's like a super wide space, and it's really exciting to see what you guys are building in terms of bringing support for new category and kind of data. Thanks a lot for sharing that, Steve.
Thanks, JB. Thanks, Cesar. Congratulations on the launch of the podcast, and really honored to be your first guinea pig.
Thank you so much. Have a great day, Steve.
Cheers. You too.